All right, we're going to be on our first lesson for advanced math for this new online digital learning. The first lesson we have here is for permutations and combinations. It starts our study of probability. This is unit, forgot what number it is, maybe 11? I think so. Anyway, on the fundamental counting principle, basically that is saying that to figure out how many ways something can happen, you multiply the number of possible or the number of ways each individual thing could happen. So in other words, like in that first sentence, it says if decision M can be made, and we're going to call it M, lowercase m, number of ways, and decision N can be made N number of ways, then the two decisions can be made M times N number of ways. So let me show you what that actually means in a problem and how you're going to see it. So notice right here we have 4 different examples. On number 1, the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose 1 flavor and 1 topping? Well, what you do is just multiply those values together. So if I have 3 cone sizes, 15 flavors, and 8 toppings. If you multiply that together, that gives you 360. So there's 360 ways. On number 2, Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? Let's see, 3 letters. So I've got 3 letters, and then I have 4 digits. So 1, 2, 3, 4. Okay, so all together, let's see the numbers, the letters. There's 26 letters in the alphabet. So that's going to be 26 for each one of those 3. And then as far as the number of numbers, digits-wise, if you do 0 all the way to 9, that's actually 10. So there are 10 digits available for all of those. So that means it's 26 to the 3rd times 10 to the 4th, which is, oh wow, that's a big number. 175,760,000. Wow, that's a lot. Number 3, Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? If there's 12 questions and each one has 2 possible answers, that's like 12 different 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or we could just say 2 to the 12th power, because nobody wants to type that in the calculator, that many 2s. You'd certainly get lost. But 2 to the 12th power is 4,096. Number 4, to enter their home, the Clayton family enters a 4-digit code. How many codes are possible? 4 digits, each one has 10 possible. So that's 10 to the 4th power, which is 10,000. So basically, finding the number of ways things can happen is fairly easy. You're just multiplying things out. The next section looks at factorials. Factorials is that exclamation point. A lot of times we see it like this. It is on your calculator under the button that says PRB. It's right above the button where the the fractions are. Let me grab mine right quick. Should have had a little bit closer to my screen. But it's right underneath the PRB button, which is the one right there. And we'll show you how to use that in just a moment. But what this means is it's the product means multiply, of all natural numbers from n, whatever the number is, down to 1. So like for example, 9 factorial, this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But no one ever wants to multiply all that out, so I'm going to show you how to do it on your calculator. First of all, let's turn it on. There we go. Clear this out. Okay, so 9, and then you hit that PRB button, and notice it's given us our 3 different ones. We're just going to tab over till we see that factorial button and hit enter, and notice it's got 9 factorial. Enter again, and it gives us that answer. So let's see, let's write that down. 3, 6, 2, 800. So right now I want you to go ahead and do these, right, and then put it in 12 factorial, 8 factorial, now that you know what it means. I'm going to do it on mine right here. And I've got a very large number for this one. So you do it, make sure you get that same number. If not, you need to let me know so I can figure out what you're doing wrong. And then on the 17 factorial divided by 11 factorial, you can simply put that in your calculator exactly like you see there. All in one fell swoop. And then that bottom one has 0 factorial. That's actually just 1. And you can verify that by plugging it in your calculator and coming up to it to show that it is 1. And I just did it on mine. So there you go. I'll turn this light on to see if it helps it out, make it a little bit better to see. I'm not sure that's working too much better. It probably would see this a little better. Yeah, we'll have to try that for next time. Okay, so the next part we're looking at permutations. Permutations is an arrangement or a lineup of objects in which the order matters. So in this blank you'd put order matters, because the order matters. It's so high. Let me fix it. Okay, order matters. The symbol for that is this right here, where it's got N and then P and then R. That is on the calculator. Actually, it's that same button where we were. If we do the PRB button, you see how it's the first one. This is our permutation. This next one is the combination, which we're going to use in this lesson also. So we'll come to that in just a minute. So anyway, the formula for this is what it actually does mathematically. Is it does n factorial over n minus r factorial. Now you don't have to memorize this formula because we're just going to use our calculator, but if you want to learn it, you can. That's what it's actually doing. N represents the total number of objects available, r represents the number of objects to use for the arrangement. So, and then they've got a shortcut here. If you got npn, this is just n factorial. Not a big deal because, like I said, we're just going to plug it in our calculator anyway. So I've got a few examples that show you what type of problems this is going to answer. So number 5, how many ways can you arrange the letters in the word dinosaur? Well, first of all, we want to count how many words we have. I mean, how many words we have. How many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8. There are 8. So 8 and then P8, because I'm arranging all 8 of them. So if you put that in your calculator, and I'm going to turn this down, that light off to see if that helps it show up a little bit better. 8P8, and you put that in your calculator, you get 40,320. Then on number 6, 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? Well, we've got 7 students we're choosing from, and we've got 3 different places. So this would be 7P3. And you put it in just like that. So I'm going to show you. Maybe I should have left this light on because you'll see it so much better on the computer if I leave that light on. Okay, so we do 7, and then hit that PRB button, enter, and then 3. So it looks like that when you enter it. And you get 210. So 210 is how many different ways here? All right, so now we're going to go on to the next page. Try to do this as quickly as we can. Okay, number 7. Melanie is taking 4 classes this semester: American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? Well, she's got to take all 4. And so this is just 4P4, which, what is that? 4P4, that 24? 24 ways. Number 8, there are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? Let's see, 16 kids to choose from, 9 that we need to choose for the batting order. So 16p9. Oh, wow, this is a very large number. 4, 1, 5, 1, 3, 4, 7, 2, 0, 0. And batting order is very important, right? My baseball players know that. Okay, number 9, there are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council representative and an alternate? Well, we got 28 people to choose from, and we need 2 positions, the student council representative and then an alternate, so 28p2, which gives us 756. So notice that these aren't bad as long as you can just plug that puppy in the calculator. It works very well. The harder ones are like 10 and 11 right here. How many different 10-letter arrangements are possible using the letters in the word automobile? Now see, this one's different than that one with the dinosaur just a minute ago. Because the one with dinosaur, we didn't have any letters that repeated. Every letter was different. But here, there's something they're repeating. So you have to make an adjustment with that. And basically, this would be the number of letters that you have on the top. So like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters, so it's 10 factorial. And then the bottom would be the number of numbers, well, it would be the one that repeats, how many times it repeats. So here, O is the one that's there twice. So I have to do 2 factorial because I have to take into account that part. So that would give us 1,814,400. And number 11, how many different 9-letter arrangements are possible using the letters in the word disappear? Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So 9 factorial on the top. The bottom, I've got 2 A's, so I have to do 2 factorial to represent that A. And then I've also have 2 P's, so I got to do 2 factorial to represent the P. And that gives us 90,720. So you put the value 1 for each one it is. So if something repeated 3 times, you'd put a 3 factorial on the bottom. Okay, so the last thing that we're looking at on this particular lesson is the combinations. Now, combinations is a group of objects in which the order does not matter. So order does not matter. Okay, so the arrangement is going to be a little bit different. That's the C word for combination. It's NCR. It's on the same button on the calculator that the other one was. You just tab over to the one with the C. So that formula is n factorial over r factorial times n minus r factorial. Now you do not need to memorize that, okay, because we're just going to use our calculator for it. But that's essentially what it's doing. And if you do NCN, it's actually just 1. You'll find that out as we go through there. So on number 12, Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? So on this one, it's not important who was asked first or second or third or fourth. They're still all bridesmaids. So that's why it's a combination. So 16C5. And then you put that in your calculator. I'll show you this first one just the same way. Turn my calculator back on. 16. Hit that PRB button and notice we got a tab over right here to get to that NCR button. Hit enter, and how many was it? 5. Enter again. 4,368. So that's 4,368. All right, on number 13, there are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? So 24C8. That gives you 735,471. Wow. Number 14, Abby is adopting kittens from the pet store. If there are 18 kittens, how many ways can she choose 2? So let's see, there's 18, C2, and that gives us 153. Number 15, there are 12 employees at the sub shop. How many ways can the manager choose 4 for the Sunday evening shift? So 12C4, that's 495. And then the last one right here, there are 85 players on the football team. How many ways can the coach choose 3 to represent the team in the coin toss? So 85C3, and that gives us 98,770. Now on the next page, because I know you have another page there, and that's going to be your homework basically for tonight. And you're going to submit all of this to Shobi when it's complete, once you've finished it all, so I can give you some points for that. This last page is asking you to figure out if it's permutation or if it's combination, in addition to determining the answer. Now, the hardest part is figuring out if it's permutation or combination, and that's where you have to decide, does the order matter? If it does, use P. If it doesn't, use C. So the key words you need to look for, if it's something that needs to be in a line, or there's different places like first place, second place, third place, that kind of thing, that's all the order matters. But if you're just picking, I don't know, like the ones we just did, the ones for the bridesmaids or the students to go to the party, it doesn't matter who was asked first, but if you're in a line, it does matter. So it's different. Like a batting order, that matters. So try this page. You're going to put P or C in this first column, and then you're going to work out the problem here with your answer. And then you're going to submit this to Shobi when it's complete. And then tomorrow we'll have another assignment. Please email me if you have questions.